What if I told you that you, me, and everyone you love almost didn't make it to today? Not once, not twice, 10 times. And the only reason we're still here isn't because of some master plan or advanced warning system. It's because of pure, dumb luck. Space looks peaceful from down here. A beautiful night sky, twinkling stars. But make no mistake, space is a shooting gallery, and Earth is the target. Asteroids the size of cities have skimmed past us. Solar storms powerful enough to send us back to the Stone Age have narrowly missed. And some of these events happened in your lifetime without you even knowing it. So buckle up, because these are the 10 space events that almost ended humanity, and the terrifying truth about how close we came to not surviving at all. Before we dive into the cosmic chaos, if you find this kind of content fascinating, hit that subscribe button and turn on notifications. We're exploring the edge of the universe and the edge of disaster. And trust me, you don't want to miss what's coming next. Event 1, the Tunguska Event. Let's start with the one that proved just how vulnerable we really are. On the morning of June 30th, 1908, in the remote Siberian wilderness, the sky suddenly split open. A blinding fireball streaked across the horizon, followed by an explosion so massive it flattened 80 million trees across an area of 830 square miles. The shockwave was felt hundreds of miles away, windows shattered, people were knocked off their feet. The Tunguska event released an estimated 10 to 30 megatons of energy. That's roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima. And yet there was no crater, no impact site. Scientists believe a stony asteroid, roughly 120 feet across, exploded in the atmosphere before hitting the ground. Here's the terrifying part. This happened over one of the most remote, sparsely populated regions on Earth. If that same asteroid had arrived just 4 hours earlier or later, it would have exploded over Europe or Asia, directly over major cities. Millions would have died instantly. The death toll could have rivaled the worst wars in history. And in 1908, we had zero warning, zero defense. We didn't even understand what had happened until years later when scientists finally reached the site. We survived because of a cosmic coin flip, a few hours difference in timing and location. Event 2. The Carrington Event, 1859. Now let's talk about a threat that doesn't even need to hit the ground to destroy civilization. On September 1st, 1859, British astronomer Richard Carrington was observing the sun when he saw something unprecedented, a massive, white light flare erupt from the solar surface. Within 18 hours, Earth was hit by the most intense geomagnetic storm ever recorded. Telegraph systems across Europe and North America failed. Operators received electric shocks. Papers caught fire in telegraph offices. The aurora borealis was visible in tropical regions, Cuba, Hawaii, even northern Africa. People in the Rocky Mountains could read newspapers by the light of the northern lights. But here's why this matters today. In 1859, we didn't have power grids. We didn't have satellites. We didn't have the internet, GPS, or global telecommunications. The Carrington event was a solar superstorm that barely scratched our technological infrastructure because that infrastructure barely existed. If an event of that magnitude hit Earth today, the consequences would be catastrophic. Transformers would explode. Power grids would collapse across entire continents. Satellites would be fried. GPS would go dark. Banking systems would freeze. Water pumps would stop working. The estimated economic damage? Trillions of dollars. Recovery time? Months to years. And we know for a fact that this wasn't a once-in-a-million-years event. Ice core samples show that storms of this magnitude happen roughly every 500 years. We're overdue. We survived 1859 because we were primitive. Today we're advanced and infinitely more fragile. Event 3, the Chelyabinsk Meteor, 2013. Fast forward to February 15, 2013. A Friday morning in Russia. People were driving to work, drinking coffee, living their lives. Then, completely without warning, a 65-foot asteroid entered Earth's atmosphere at 41,000 miles per hour. The resulting explosion, 30 kilometers above the city of Chelyabinsk, released the energy of 500 kilotons of TNT. That's 30 times the power of the Hiroshima bomb. The shockwave shattered windows across 6 cities, damaged 7,000 buildings, and injured 1,500 people, mostly from flying glass. Here's what makes this truly terrifying. We never saw it coming. NASA's Near-Earth Object Program, which tracks potentially hazardous asteroids, completely missed this one. It approached from the direction of the sun, hidden in the glare. We had zero warning. If it had been just slightly larger, say 150 to 200 feet, and hit at a slightly different angle, it could have struck the city directly. Tens of thousands would have died. And remember, this was 2013. We have telescopes, we have space agencies, we have computer models, and we still didn't see it until it was exploding in our atmosphere. We survived Chelyabinsk because the asteroid was relatively small and exploded high enough to dissipate most of its energy. A slightly bigger rock, a slightly lower explosion, and we're talking about a city wiped off the map. Event 4, the 2012 solar storm near miss. You want to know how close we came to societal collapse? This one will keep you up at night. In July 2012, a massive coronal mass ejection erupted from the sun. It was a Carrington-level event, possibly even stronger. The resulting solar storm tore through Earth's orbit. We missed it by 9 days. 9 days? Earth had already passed that point in its orbit 9 days earlier. The solar storm hit the spot where our planet would have been. If the eruption had happened just over a week sooner, Earth would have taken the full force of the blast. NASA later calculated that the recovery time from such an event would have been between 4 and 10 years. That's 4 to 10 years without reliable electricity. No refrigeration, no clean water pumping, no fuel refining, no telecommunications. Modern civilization runs on electricity, and we would have been thrown back to the 1800s overnight. The cost? An estimated $2 trillion in the first year alone. But the real cost would have been measured in lives, hospitals without power, supply chains destroyed, social order breaking down. We didn't dodge this bullet because of our technology. We dodged it because of orbital mechanics and blind timing. 9 days. That's the margin between our connected world and absolute chaos. Event 5, Apophis, the Doomsday Asteroid. In December 2004, astronomers discovered an asteroid that sent shock waves through the scientific community. They named it Apophis, after the Egyptian god of chaos. Initial calculations suggested a 2.7% chance that it would strike Earth on April 13th, 2029. That doesn't sound like much. But in asteroid terms, that's terrifying. Apophis is roughly 1,100 feet across. That's wider than the Eiffel Tower is tall. An impact would release energy equivalent to over 1,000 megatons of TNT. It wouldn't be an extinction-level event, but it would be a civilization-altering catastrophe. A direct hit on a populated area could kill millions. An ocean impact could generate tsunamis hundreds of feet high, devastating coastal regions across entire continents. For months, Apophis remained at the top of NASA's impact risk list. It was the most dangerous asteroid ever tracked. Later observations refined the trajectory and ruled out the 2029 impact. But here's the unsettling truth. Apophis will pass within 19,000 miles of Earth in 2029. That's closer than some of our own satellites, and its path will be altered by Earth's gravity in ways we can't perfectly predict. If it passes through a specific gravitational keyhole in 2029, it could be set on a collision course for 2036 or beyond. The odds are low, but they're not zero. And we currently have no operational planetary defense system capable of deflecting an asteroid of this size on short notice. We survived the initial Apophis scare because better data improved our predictions. But the asteroid is still out there, still coming close, and we still can't do much about it if our luck runs out. Event 6. The 1972 Great Daylight Fireball. On August 10, 1972, thousands of people across the western United States and Canada saw something extraordinary, a massive fireball streaking across the afternoon sky. It was visible for over 100 seconds, an eternity for a meteor. Scientists calculated it was an asteroid roughly 10 to 15 feet across, weighing thousands of tons. But here's the critical detail: it didn't hit the ground. It skipped off Earth's atmosphere like a stone across a pond, arcing back out into space. If it had entered at a slightly steeper angle, it would have detonated with the force of a nuclear weapon. Over a populated area in broad daylight, in 1972 during the height of Cold War tensions. Imagine the consequences: a nuclear-level explosion over the United States or Canada with no warning, no explanation. In an era when radar systems were primed to detect Soviet missiles, the potential for misunderstanding, for escalation, for accidental nuclear war is horrifying to consider. We survived because of atmospheric physics. A few degrees difference in entry angle, and we're not just talking about a meteor impact. We're talking about a potential trigger for World War III. Event 7, the 1989 Quebec electrical blackout. On March 13, 1989, a powerful geomagnetic storm triggered by solar activity caused a 9-hour blackout across the entire province of Quebec, Canada. The storm induced currents in power lines that overwhelmed the grid. 6 million people lost electricity in the middle of winter. The blackout extended into the northeastern United States. This wasn't a Carrington-level event. This was a moderate solar storm. And it still took down an entire provincial power grid. The storm also damaged transformers, disrupted radio communications, and created phantom signals in undersea cables. Satellites tumbled out of control. One satellite was damaged so severely it was declared a total loss. Now scale that up. Imagine not one province but an entire continent. Not 9 hours, but 9 months. That's what a Carrington-level storm would do. The 1989 event was a warning shot, a reminder that our electrical infrastructure is far more fragile than we like to believe. We survived 1989 because the storm was relatively contained and our grids, while damaged, were repairable. But it proved that even a moderate space weather event could plunge millions into darkness. We got lucky that day. Next time we might not be so fortunate. Event 8. The 2004 MN4 Scare. Before Apophis captured headlines, there was another asteroid that briefly held the title of most dangerous object in space, 2004 MN4. Discovered in 2004, initial calculations gave it a roughly 1 in 300 chance of striking Earth in 2029. That risk was quickly downgraded as more data came in. But for a brief period, scientists were genuinely concerned. MN4 is about 1,000 feet across, large enough to cause regional devastation if it struck land, or massive tsunamis if it hit an ocean. The scare highlighted a fundamental problem. Our asteroid detection systems are incomplete. We find most near-Earth objects through ground-based telescopes, which can only observe certain parts of the sky at certain times. Objects approaching from the direction of the sun, like Chelyabinsk, are essentially invisible to us. We survived the MN4 scare because further observations ruled out impact. But the underlying issue remains. There are estimated to be tens of thousands of near-Earth asteroids large enough to cause significant damage. We found maybe 40% of them. The rest are out there, unseen, uncharted, and potentially on collision courses we won't detect until it's too late. Event 9. The 2020 VT4 Close Approach. On November 13, 2020, an asteroid named 2020 VT4 passed within 240 miles of Earth's surface. That's closer than the orbit of the International Space Station. It's one of the closest near misses ever recorded. Here's the kicker. We didn't see it coming until 6 hours after it passed. 6 hours. 2020 VT4 is estimated to be between 15 and 30 feet across. If it had entered the atmosphere, it likely would have exploded high up, similar to Chelyabinsk, but potentially more destructive due to its size and proximity. But the real terror here isn't the size. It's the detection failure. An object passed closer to Earth than our own space station, and we missed it entirely until it was already gone. Our planetary defense systems failed to detect it because it approached from a blind spot from the direction of the sun. If it had been on a collision course, we would have had zero warning, zero time to evacuate, zero time to prepare. Just sudden impact. We survived 2020 VT4 because it missed. But it exposed a terrifying vulnerability in our ability to detect incoming threats. We're flying blind in a cosmic shooting gallery, and sometimes the bullets pass so close we can feel the wind. Event 10. The Betelgeuse Supernova Threat. Let's end with something that hasn't happened yet, but could at any moment without warning. Betelgeuse is a red supergiant star, roughly 640 light-years from Earth. It's one of the brightest stars in the night sky. It's also dying. Astronomers believe Betelgeuse could go supernova anytime in the next 100,000 years. That sounds like a long time, but in stellar terms, it's essentially tomorrow. When Betelgeuse explodes, it will release more energy in a few seconds than our Sun will produce in its entire 10 billion-year lifetime. The explosion will be visible in daylight. It will outshine the full moon for weeks. At 640 light-years, we're probably outside the lethal gamma-ray burst zone. Probably. But supernovae are unpredictable. If the explosion is asymmetric, if jets of gamma radiation are ejected in our direction, the consequences could be devastating. Gamma rays would strip away our ozone layer, exposing the surface to deadly ultraviolet radiation. Ecosystems would collapse. Food chains would break down. And we would have no warning. Betelgeuse is 640 light-years away. If it exploded 639 years ago, the light and radiation would reach us tomorrow. We wouldn't know until it arrived. We survive Betelgeuse every day because it hasn't exploded yet. But it will. And when it does, we'll find out if 640 light-years is enough distance to survive one of the most violent events in the universe. So there you have it. 10 times space tried to kill us, and 10 times we survived by sheer luck, timing, distance, blind chance. The Tunguska asteroid missed our cities by hours. The 2012 solar storm missed us by days. Chelyabinsk came without warning. Apophis still haunts our future. And Betelgeuse could end us tomorrow without us ever seeing it coming. We've built an advanced civilization on a rock flying through a cosmic minefield. We track some threats, but we miss others. We're developing planetary defense systems, but they're years away from being operational. And the universe doesn't care about our schedules. The truth is our survival isn't guaranteed. It's not even likely. It's a streak of good fortune that could end at any moment. So maybe instead of taking our existence for granted, we should appreciate just how improbable it is that we're here at all. Space is beautiful, but it's also indifferent. And our luck won't last forever. If this video made you look at the night sky a little differently, smash that like button and let me know in the comments which event terrified you the most. And if you want more content that explores the edge of possibility and the brink of disaster, subscribe now and hit the notification bell. Because the universe is full of stories, and some of them are trying to kill us. I'll see you in the next one. Stay curious, and maybe, just maybe, keep one eye on the sky.